So this is section 3.2, question number 20. I had a lot of email requests for help on this, and so this is my version. Make sure that you do your own version, but it's similar to mine. So we have a cardboard box with a square base, with each edge being x on the base. The height, we're going to call it y, and it's saying here that the total length of all the 12 edges is 144 inches. I'm going to switch over to my paper here and have a little picture of this box. I'm going to call this y. So all these are y. If you add up all these edges, you get 4x, and then you have another 4x from the top, and then you have 4 of these y's, so 4y. I'm going to set that to equal 144 because that was given to me. I'm going to combine like terms, so I have 8x plus 4y equals 144. Let's solve for y because we need the volume v as a function of x. Okay, so 144 minus 8x. I'm going to divide everything by 4. That's 36 minus 2x. Okay, so the volume is length times width times height. So in this case, it's x times y. And we're going to plug in y. And so this is x times x is x squared times 36 minus 2x. So let's go enter that into WebAssign. So you have x squared times 36 minus 2x. All right, I'm going to submit that. And it should be correct. What about the domain? The main thing is that normally a polynomial's domain is all real numbers, but this is a practical case. So we need to make sure that x is greater than 0, and you also want this height, 36 minus 2x, to be positive. So let's go back here and see what that means. If I solve for the zeros, I can take out a 2 from there, and I have 18 minus x. So the zeros are 0 from here and 18. So you want the domain to be, for x, needs to be between 0 and 18 for this box to be a box so that you don't have any negative values. Okay, so let's go and enter that in. It says to use interval notation, so parentheses 0, 18, close the parentheses. And then finally we need the graph. We'll come back to that in a second. So for the graph, we're looking for, let's go back to our polynomial when it's fully expanded. This would have been 36x squared minus 2x cubed. So it's a cubic. Okay, so cubic with a negative, odd degree, negative leading coefficient. This is the shape, but we're only looking from 0 to 18. Okay, so we'll have to check and see which of those options given will match. Again, you can check the scale using your calculator and pick the right graph. Okay, so we'll come back to that in a minute. The last part is just to find the volume of the maximum volume. So once you pick the graph, that'll pretty much do it. So on the x-axis, notice that it's going from 0 to 20. So I'm going to change that in my graphing calculator. And the scale is going by ones, the tick marks, that is. And then from here to here, it's going from 0 to 2,000. And let's go by 100s. I'm going to type that equation into my calculator. So let me just scroll up here so you can see that all of these are going up to 2,000. So in y equals, we're going to type in x squared times 36 minus 2x. I'm going to show you under my document camera what the graph looks like. Okay, and you can find the maximum as well using the max button. Left bound, it's on the left of the high point there. For the right bound, go over. To guess, go in between a little bit. And this is what I'm getting. I don't care about the x value. It's the volume that I want. So it's 1728. So we'll go and enter that in. And then pick the appropriate graph that goes with it. 1728. So it's clear this is too low. It could be this. Let's check the other two just to be safe. Yeah, that's too low. So it's definitely, so you needed to find the maximum to be able to do this. All right, let's submit that. Let's see. Yep. Okay, hope that helps.